Okay, 1.3, identifying unknown line segments. We went over this today, but we're just going to make sure that everything is really clear for you so that you can do this without any problem. Okay, so on the screen here, I have an unknown line segment. It is green inside that little grid space there. Your goal is to take what you know about triangles, squares, square roots, all of that information, pile it all up into a nice little bundle, present it mathematically, and tell me how long that is. No, you can't use a ruler, although that would seem like the most logical option. It's good for your brain. It's like exercise to do it this incredibly difficult and convoluted way. I've got some calming music in the background. So get your notes out, have a look at those, use them as a reference. We'll go through one as an example. I'll tell you how it will be marked on an assignment, and then you should be good to go. All right, first off, our green line. Remember that in class we talked about seeing that not as a line, but rather as a triangle. So this particular line, if we were to see it as a triangle, it would look a little bit like that. So that triangle now that we've taken, we're going to clone that triangle. We're going to clone it, and when we clone it, we're going to rotate it. Everything is going to rotate clockwise. So you'll see that our triangle has 1 unit, 2 units, 3 units high, and 1 unit, 2 units, 3 units wide. So when we rotate, we're going to rotate clockwise, right? So everything's going to go this direction. So we're going to move this way and turn it up. So we're going to call this our A line and this our B line. So if we rotate this triangle, we're going to slide it over so that our A is on the bottom and our B becomes our height. So our A now is going to be 1, 2, 3. Our B is going to be 1, 2, 3, and we are going to join those together to make a new triangle. So we slid that over and then onto its bottom. We're going to do the same thing now upwards. So again, remembering that now this is A and this is B. We're going to slide that up, turn it so that our A is once again on the back side and our B is on the top. So we're going to go up 1, 2, 3, over 1, 2, 3, and join them. We're going to do the exact same thing one last time. This time our A is going to be up here and our B is going to be over here. 1, 2, 3, and 1, 2, 3. Now, if that all worked out correctly, what you should have is a nice straight square. If you've got little bits jabbing out on the edge, or something's on an angle, or it's sloped, something went wrong, erase all your triangles and go back and give it another whirl. Once we've got our shape drawn, we now have our information. So we can get rid of all the stuff that might confuse us. So we can get rid of these letters, which you never need to draw. All I'm doing that for is to show you the rotation of the triangle. So don't feel like you need to draw that. You just need to be able to turn that triangle into something that has an internal square. So the first thing we're going to do when we get to the math, we're going to now find out what is the area of one of our triangles. We represent that by simply drawing an A of a triangle. It is important that you put this here because I want to see that you can follow the steps, okay? So when we're finding the area of a triangle, you'll remember that the area of a triangle is A equals base times height all over 2. You don't need to draw the formula when you're doing the math on your assignments, but for the purposes of this example, I'm going to put it in. So area equals, the base is the bottom, this is our base, and this is our height. So the base of the triangle that I have here is 3 times its height, which is also 3. All that's over 2. 3 times 3 is 9 over 2. The area equals half of 9 is 4.5. We're going to call these centimeters squared. It's important to have the units, and it's also very important to make sure that you have it squared because we're talking about area. Next up, we have the area of all of our triangles. So now we need to find the area of all of our triangles. We know that each triangle is 4.5 because they're identical because we drew them that way. So each one of these is 4.5. So we've got an area of 4 triangles. Area of 4 triangles, just like we did over here, area equals 4 times our triangle, which is 4.5. Area is going to equal 18. We've established that it's centimeters and we're dealing with area, so you got to have that squared in there. The next thing that we're going to do is we are going to find out the area of our large square. So that's how I call it a large square. Remembering that when we're talking about that large square, we're talking about this big square on the outside of everything that we've done. Okay, so we're talking about that, not the internal square. We're talking about this outside square. And we can tell how big that is by simply counting up. 1, 2, 3, 4, 5, 6. It is 6. 6 by, if it's a square, that number better be the same. And it is, it's 6. So 6 by 6. The area of our large square is 36 centimeters squared. Okay, so now we're down to the last 2 steps of finding out. What we want to do now is we want to cut away our triangles to identify the area of that center square. Because once we have the area of our center square, we find the square root of that square and we've got our unknown line segment. So we do that by saying we want to know the area of our small square. The area of the small square is simply the area of the big square, which our large square, which we said was 36, and then we subtract or take away the area of all of our triangles, which we established right here, is 18. I'm even going to put that in red just to make sure that it's clear. Subtract 18, and that's going to equal 36 take away 18 is 18. So we end up with an area of 18. So our central square here equals 18 centimeters squared. What we need to do now is find the area, or pardon me, we have to find the square root of 18. So if we want to know our line length is equal to, our unknown line length is equal to the square root of our small square, which we've identified as 18. Now in class, we have a couple of people who did this. I think it's a great idea. If we have the square root of 18 on the left or the lower side, the next perfect square is 16. Okay, so I would just put a little 16 down here. And above 18, the next perfect square would be 25. We know that the square root of 16 is 4, and the square root of 25 is 5. So 18 is quite a bit closer to 16 than it is to 25. So we're going to call that square root there equal to about 4.2. And again, no squared here because now we're talking about length. So essentially what we've done, if we erase all of this stuff that we have here, we've identified what our line length is. So our line length from here to here, because we found that square area, the square root of the area of that square, is about 4.2. For an estimation, that's awesome. Okay, so if we back it up, we've got to remember we have all that math to support our answer. and it tells us that our line length is 4.2.